Okay, well, greetings, fellow scientists. I would like to welcome you all to the Wisconsin Science Festival online field trip with Sam Shakashiri and Science is Fun and the Joy of Learning. My name is Jo Withers. I'm part of the Wisconsin Science Festival team, and we are here with our special guest, Sam Shakashiri. We would like to let you know how to participate with us today. Your picture and audio are going to be muted, but if you have any questions that you would like to ask, you can use the Q&A feature. As soon as you have those questions, go ahead and put them into the Q&A right away, and we'll ask as many of them as possible during the field trip. This will be recorded, and as always, we ask that you do this in all activities at the Science Festival with a responsible adult. We would like to thank all of our sponsors and partners that help make the Wisconsin Science Festival possible. You can find out more activities and events during the festival at wisconsinsciencefest.org. With that, I am excited to get started. Take it away, Bassam.
Good afternoon, and welcome to this very special part of the 10th Annual Wisconsin Science Festival. I'm so happy you can join me, and I promise you a good time if you pay attention, and even a better time if you think about what I'm sharing with you and ask questions. I'll try to answer all of your questions, but if I don't get around to all of that, then you can count on sending them via email and I will answer them. This is a very exciting time of the year. We have color changes all around us. I'm really interested in color. When I was growing up in my native Lebanon, my mother knitted a sweater for me. It was a yellow sweater. I wanted to know what yellow is, so I asked her, and she said it's made of wool. I said, well, wool comes from sheep, and sheep are not yellow. I kept asking questions, and I always got encouragement from my parents, from my teachers, from everyone else. And I was patient. Sometimes I would not get the answer that I was looking for immediately, but I learned how to be patient. And this is how we learn, by paying attention to what goes on around us and by asking questions and trying to think about the observations we make and the conversations we have with each other. So I'd like to go to the next slide, please. And there is our mascot for the Wisconsin Science Festival. You can see that the mascot is obeying the safety rules by wearing a mask. We always wear masks now. It's part of personal hygiene. We always pay attention to what we must do safely. And the next slide, please. You can see that there are activities in the Wisconsin Science Festival all over the state. And this is a very satisfying development for me because I'd like everyone in our state to participate in science activities, not only during the Science Festival, but every day, because we live in a beautiful, complex world, and we need to understand what it is that is going on around us. And we always have to focus on being creative. Next slide, please. You can see in this slide here, a young woman playing the violin. Creativity in science, in the arts, in the humanities is very important. It cuts across all kinds of disciplines. So those of you who play music, thank you for doing that. Those of you who want to engage in scientific experiments, thank you for doing that. So we go on now to showing a slide. This slide shows what's going on around us in the environment. The changing of the colors of the leaves. It's one of the questions we ask. We're all curious. Why do the leaves change color in the fall? Why do they change color in the fall? They change color in the fall because oh, look at that. This is a beautiful picture of a beautiful set of trees taken in Madison. We go to the next slide.
Sam, A lot of students have said that they have trees that look like that right around them now.
Say that again?
That a lot of the students have said that they have a lot of trees that look like that at their homes now.
Fantastic. I'm so glad that you're always looking outside and enjoying nature. And we look at these different colors. The trees begin to change color in the fall because the amount of sunlight goes down. The temperature also falls down, and the humidity in the air falls down. And this begins to shut down the giant factories that the trees have to make chlorophyll. Chlorophyll is a green pigment. And all of these colors that we see now and we enjoy looking at now are there, but they are masked. They're covered by the green pigment. But when they start shutting down because of changes in the amount of sunlight, the amount of humidity, and the lowering of the temperature, then they are revealed. And then when the leaves die, they drop off. So this is a fascinating experience. We learn from it. We learn about carbon dioxide, and we learn about photosynthesis and how carbon dioxide combines with water in the photosynthetic process. So we go on now to an experiment that has to do with carbon dioxide. And I'd like to show you this experiment. I'd like to show you a clip of what goes on when we use carbon dioxide with a variety of liquids.
What I have in this bucket here is some carbon dioxide, except it's not in the gaseous form. It is in the solid form. It's called dry ice. So I put my gloves on, and I try now to get a chunk of dry ice and set it right here. This is solid carbon dioxide. It is at a temperature of minus 78 degrees Celsius. It's very, very cold. And that's why I wear the gloves. This solid is changing into a gas directly without melting. When a solid changes from being a solid to a gas without melting, we call that sublimation. Can you say sublimation? Sublimation. Sublimation is happening right now, but we can't see it. How come we can't see it? Because carbon dioxide gas is mixing with air, which itself is a mixture of gases. I want to ask you to focus your attention on what you see between my two hands right here. What shape are these objects? Cylinders. And how many cylinders are there? Six. And they have in them what looks like colored liquids. We know they're liquids because from experience, we know what liquids do when we shake them up. And they seem to be arranged in some kind of order. This pair has what color liquid? Blue. This one? Pink. This one? Purple. All right, so what I'm going to do now in this experiment, I'm going to take chunks of dry ice, and I'm going to drop them into these cylinders, and we'll see what happens as I drop the dry ice in every other cylinder, not in every cylinder. Does this help see it better? All right. Do you see bubbles? Those are carbon dioxide bubbles coming from the sublimation of dry ice. We see them there because a gas is mixing with liquid. Over here, we don't see them because gas is mixing with air. We also see beautiful color changes, right? And we see something coming off the top here. It looks like smoke, but it's not really smoke. It is a mist. It is the condensation of water vapor on the cold carbon dioxide gas that's coming from the sublimation process. But some of the carbon dioxide gas dissolved in the liquid and caused the color changes. So each of these pairs had in them dyes, and these dyes change color depending on how acidic or basic a substance is. To begin with, all the cylinders had in them a basic substance and different dyes, 3 different dyes. And then when carbon dioxide dissolves in water, as we have in carbonated beverages, we get carbonic acid. We drink carbonic acid. It's safe to do. But you see the color changes are because of the acid-base reaction that we have used, and these dyes, when they change color, they indicate to us that a reaction has taken place. That's why they're called acid-base indicators. they indicate a chemical change. Do you like this experiment? Yeah. Thank you.
Sam?
And I'm going to do an experiment with the hot boiling liquid that I have here. The one that I have here is water. I'm going to use my gloves now to protect my hands from heat. And I have some dry ice here, but actually I'm missing, whoops, I'm missing a dishpan. Let's see if I can find it. Could someone please bring me the dishpan? Would someone please bring me? Hello, Bucky. Good to see you, Bucky. And welcome to my lab. Thank you. This is what I really wanted to do. So Bucky, would you like to help me with this experiment? You notice that Bucky is a good science student. He's wearing his eye protection. I want everyone to see that. And so, Bucky, here's what I'm going to do. I'm going to take the boiling water. I'm going to put it in this dishpan that you brought me. And what we see coming off the top here, what does it look like? Steam isn't visible. You can't see steam. We see a mist. That's what we're seeing. The mist of water vapor. And then, Bucky, here's the experiment. You take this bucket right here, and you pour all the dry ice that's in there into the boiling water. Go ahead, Bucky. Do it, all the way, all the way. That was very, very nice, Bucky. Does that look like steam? No. It looks like fog. Looks like fog, and that's what it is. We just made a lot of fog here. You notice that the fog is moving downward now because carbon dioxide gas is denser than air. The condensation is on the carbon dioxide gas that's coming from the sublimation reaction.
Carbon dioxide is a greenhouse gas, and we have to pay close attention to our human activities that put a lot of greenhouse gases, especially carbon dioxide, into the atmosphere. And that's why I'd like to show you the effect of global warming on our state. If I could have the next slide, please. This is a display of the plant hardiness zones in Wisconsin between, taken in 1990 and then 2012. And you can see that the movement is upward. The scale and the colors tell us about the plant hardiness zones. And global warming is real. It is caused, of course, by natural causes, but human activity contributes a great deal more to global warming. And carbon dioxide is a greenhouse gas. It comes from the combustion of fossil fuels. We all have to lower, hopefully eliminate our dependence on fossil fuels, because when we burn fossil fuels for energy, we produce carbon dioxide. A lot of carbon dioxide is being put up in the air. I'll show you this on the next graph, in the next slide. This is a display of the amount of carbon dioxide as measured on the top of an observatory in Hawaii. And you can see that there's no doubt about it. The amount of carbon dioxide gas in the atmosphere is increasing, again, because of human activity. And we have to be very, very careful about lowering our dependence on fossil fuels. All of these pieces of information are on my website. I invite you to go to my website and learn more about how we measure carbon dioxide and about the effect of carbon dioxide on lakes and oceans, something called ocean acidification, the lowering of the pH in the ocean as a result of increasing amounts of carbon dioxide in the atmosphere. Well, now I'd like to have you watch another experiment that, guess what, relates to carbon dioxide. So please roll the tape.
Hi, have you ever seen this type of cleaner? It's used to clean bathroom tiles. So I'm actually standing in my tub in my bathroom, and I'm going to do a few experiments with this. Watch what happens when I spray this on the wall. It goes on blue. It's a nice blue color. Let's sit here and watch. Do you notice the color fading over time? Looks a little white here. It still looks blue here. It sure looks to me like the color of blue is fading. Huh. I wonder how this color change happens. You know, let's do some experiments and find out.
I wonder if there's something in the air that's causing the color change to blue. To test this idea, I'll spray the cleaner onto some aluminum foil. Next, I'll cover a portion of the foam with this plastic cup. The cup will prevent fresh air from reaching the foam that's covered by the cup. The portion of the foam that is not covered with the cup will interact with fresh air. Let's watch and see what happens. It looks to me like the foam is changing from blue to white just like before. I wonder what's happening under the cup. Hey, look! The portion of the cup that was protected from the air is still blue. I think this is evidence that something in the air might be reacting with the foam to cause the color change.
I wonder if it's carbon dioxide or CO2 that's causing the color change. We can test this idea by breathing through this straw onto the foam. You see, carbon dioxide in exhaled breath is 100 times more concentrated than it is in the air. So if carbon dioxide is causing the color change, my exhaled breath should do the trick a lot more quickly.
Okay, let's spray 2 portions of cleaner onto the foil. Now I'll exhale through the straw onto this spot over here. Wow, the spot I breathed on changed color right away. Maybe carbon dioxide is causing the color change. I want to try another test. This home carbonation system pumps carbon dioxide into water to make sodas. First, I'll use this system to fill this bottle with CO2. There. This bottle should now be filled almost entirely with carbon dioxide. Now let's spray some foam onto the foil for our test. Alright, now we'll pour some of the carbon dioxide gas in this bottle onto the foam. Would you look at that? Pouring the carbon dioxide gas causes the foam to immediately change to completely white. That is really neat. I think we now have a lot of evidence that carbon dioxide is causing the color change. What causes this color change? Well, the cleaner contains a dye that's blue above pH 9, but colorless below this pH. You might remember that pH refers to how acidic or basic something is. Substances with a pH above 7 are basic, while those with a pH below 7 are acidic. The cleaner has a pH above 9, so the dye in the cleaner appears blue when it's first sprayed out. When the air contacts the cleaner, carbon dioxide in the air dissolves into the foam, and CO2 reacts rapidly with basic solutions. Carbon dioxide causes a drop in pH when it reacts with basic solutions. So when enough CO2 dissolves into the cleaner to cause the pH to drop below 9, the color changes from blue to white. Scientists have discovered that the amount of CO2 in the air is increasing. This extra CO2 builds up in the air when people burn various types of fuel, like gasoline, for energy. Just like carbon dioxide causes a drop in pH when it mixes into the foam, the CO2 in the air also gets into our oceans and makes the pH of the oceans drop. You can probably imagine that this drop in pH of the oceans is causing problems for sea life, and this may become a problem for the people who depend upon life in the oceans. I hope you enjoyed learning a little bit about this special cleaner and how carbon dioxide makes it change colors. Thanks so much for watching.
And thank you all for joining me today. I have a couple of other things that I would like to share with you. Do you always believe what you see? Do you really always believe what you see? Let's try to do an experiment together. Let's try here. Can you see what I have? I have a card with 2 arrows. And now I'm going to take a glass of water. This clear and colorless liquid is water. And I'm going to lower. Can you see what has happened to the arrow? This is actually.
Several people have said it's changing direction.
Say again, please.
Several people have said it's changing direction.
It is changing direction. What makes it change direction is the water. You all know this from experience. Do you remember sitting on the side of the pool and putting your leg in the water? Does your leg look straight? Or you can take a pencil and put it in a cup of water. You can see it bent. So always think about the observations that you make and always ask yourself, do you always believe what you see? We learn by asking questions. We look up in the sky when it's raining sometimes and the sunshine is out and we see a rainbow. A rainbow is an illusion. So we have a lot of illusions. There are 2 types of illusions. There's an optical illusion and there's a visual illusion. So we ask questions. What is an optical illusion? What is a visual illusion? And how do we actually perceive the information that we get through our eyes, through our ears, and through all the senses, the touch sense, smell, and taste? We're always asking questions and we try to satisfy the curiosity that we have. And if you don't ask questions, you're robbing yourself of the joy of learning. And that's why I encourage you to visit my website and look at the experiments that you can do at home. You go to my website, scifun.org, scifun.org, and you can find in the upper left corner a place where you click and you can download the experiments, including the one I just showed you. With the arrows and other illusions, optical and visual illusions. You can also go to our YouTube channel and see more videos that display scientific and very interesting phenomena, such as the one that was done with the kaboom. So here is a slide showing one person in my group. She's graduated now from my group. She is now lecturing at UW La Crosse. She's blowing soap bubbles into a fish tank at the bottom of which there is some dry ice. And this is an experiment you can do at home. Well, you might say, how do I get dry ice at home? Well, you don't need dry ice at home to produce carbon dioxide. You can take some baking soda, put it in a dish at the bottom of the fish tank, and add some vinegar. And you see bubbles. You'll see bubbles, and those bubbles are carbon dioxide bubbles. You can try the very same experiment that's being shown here using a bubble solution. See how you can float the soap bubbles on carbon dioxide. So lots of experimentation, lots of questions to ask, and always, always think about the answers that you come up with and the answers that you hear from other people. And be skeptical about the answers, because this is how we make progress in science, by asking questions, by being skeptical, and trying to make sense of what we see and what we do and what we experience. That is the joy of doing science. That is the fun of doing science. And I'd like to make sure that you all know how to get to my Science is Fun website. This is, you go to the YouTube channel on the Science is Fun website. This is where you can find it. And I do want to thank you all for joining me today. If you have questions, type them in, send them in, and make sure that you tell me what your email address is so that I can respond to them. And I promise I will respond to all questions except one. I will not help you with your homework problems.
So unfortunately, I think we've lost Sam. We've been having some technical difficulties. So thank you everybody for understanding. They are some really cool experiments. So do please check out the Science is Fun website. I know I was going to ask him some questions that had come in, and one of those was what his job was in science. But Sam Shakashiri is a professor at UW-Madison, and at the University of Wisconsin in Madison. So thank you everybody so much for joining us at the Wisconsin Science Festival. Thank you, Bassam, so much for joining us today. Remember that the Wisconsin Science Festival continues all weekend with events hosted from organizations across the state that you can participate in. Just check out wisconsinsciencefest.org for more science fun. And a lot of our videos will be recorded over the weekend, so you will have a chance to see them again. Again, I'm sorry about the technical difficulty, and make sure that you check out the Science Festival this weekend. Thank you, everybody. Take care.